Welcome back to my channel, Spark Virtual Academy. Today we are going to learn about physics again. In my last lecture, we learned about the parallel forces, and I told you about its types like the like parallel force and unlike parallel force. You can watch that lecture from my channel. I will put the link of the lecture in the description box. So you can just watch it and it will be easier to understand this chapter further after listening that lecture. So today, the second topic of the chapter is torque. Okay, torque. The torque is also known as the moment of force. Okay, so there is no any need to be confused by getting this name. So moment of force or torque, that both thing is same thing. Okay. Now remember, this torque is denoted by this Greek letter that is the tau, T-A-U. Okay, it's very simple. It's not like T, but uh, like in Urdu we can just write down like this and इसके ऊपर हम देते हैं आ अलमंद आ वाला ठीक है. So that becomes the top. That is the symbol of the torque. In simple words, if we talk about the definition of this torque, so that torque means the turning effect. Okay, the turning effect of any body is known as the torque. Okay, so now what do we mean by the turning effect? So let's take an example. You might have seen this example in your schools, the seesaw. Here you are. Okay, so if we put a body A here and if we put a body B here, and that is the mean position, the fixed position. Okay, that is the mean position. Now let's suppose this marker, if it is fixed right here and this like this picture. Okay, if this is fixed at this point, now it can turn here and there. Okay, if we are applying the force from this side, it is moving down, and if we are applying the force from this direction, it is moving down towards that direction. Okay, so like the seesaw in our schools, it is the example. Now that fixed point is known as the mean position here in the terms of the torque. And now from this mean position, that distance towards the end of that A, okay, from 0 to A. Now that 0 to A is known as the moment arm. Okay, now the distance is known as the moment arm. It means moment arm is the distance from origin to any end. Okay, it is not necessary that that fixed point is always in the center of anybody. Okay, that fixed point can be at the corner, like the door. You can see the door, it is fixed from the one end, and that complete door is the moment arm. Okay, that is the complete distance, because this is the fixed point and this complete distance is the moment arm. So like the door opens like this, so it is turning, so it means it has the turning effect. Remember, turning effect means just move here and there. It doesn't revolve around. Okay, for example, if I have this marker and if it is revolving, so that would not be the turning effect. Turning effect means just moving here and there, whatever the fixed point is there. Okay, so now that was the moment arm. So if we talk about this torque mathematically, if we talk about this torque mathematically, or if we talk about its formula, remember, this torque is always equal to the product of moment arm and force. Okay, the force that we apply here, that force, as I told you, for example, this is fixed and I'm applying the force there. Okay, to move this marker up and down. So we can write down, instead of this torque, that will be the symbol torque, and moment arm you can write down. Okay, this distance is denoted by r. Okay, or even you can mention s. Okay, but particularly for the torque, we denote this moment arm by the small r. So we can write down, instead of moment arm, r, R and multiplied by force. That is the force. It means this torque is the turning effect of any body, and I gave you the example. And we can say that mathematically, or if we talk about the formula of the torque, it is always equal to the product of moment arm or the distance into the force multiplied by the force. Okay, as you can see there, there is the arrow upon the head of the torque, so that torque is a vector quantity. Okay, so if it is vector quantity, it must have the direction. So what would be the direction of this torque? There might be only two directions of the torque. If you can see this marker, if I'm applying this force from this direction, so it is moving downward, that is the anti-clockwise direction. But if I am applying the force from this direction, so it will move like this in the clockwise direction. So there may be only two directions of the torque. Okay, so the torque may be clockwise torque, okay, or the torque may be anti-clockwise, or we can say that that is the counterclockwise. Okay, okay, if it is clockwise, it will move in the direction of the clock. If it is anti-clockwise, it moves away from the clock's direction. Okay, remember, if there is the clockwise torque, it is always in negative. Okay, the clockwise torque is always taken as negative, but if it is anti-clockwise, it is always taken as the positive torque. Okay, so if I am pushing this in this direction, now that is the anti-clockwise direction, so here the torque will be positive. But if I am pushing this in this direction, so here the torque will be negative if it is moving in the clockwise direction. Okay, okay, the SI unit in which we measure the torque is always equal to, as you can see there, Newton and meter. Okay, the SI unit, the fundamental, the SI unit or the Anker's unit of this torque in which we will measure, it is equal to Newton meter. Newton for force and meter for this distance. Okay, so you have to just memorize certain things here. Okay, one of the thing is that you have to memorize this picture and you have to understand the concept of turning effect. That what do we mean by the turning effect? It is separate from the revolutions. Okay, the turning effect means just moving to and fro like this from a fixed point, and then you have to understand the product of these both. Then you have to understand this momentum. Momentum means the distance from origin to any endpoint. Either it is the distance from 0 to A, it is also the momentum. If you talk about this distance 0 to B, it is also the momentum. Remember, in torque, you are not supposed to take two arms together. You have to just pick one arm, means from origin to any one of the end, that would be the moment arm, an arm which it will move. For example, this distance, or you can take this distance only. And then it is the vector quantity. It means it has two directions only. Either it can be in clockwise direction or it can be in anti-clockwise direction. If the torque is in clockwise direction, then we will take the torque as the negative, but if it is in the anti-clockwise direction, then the torque will be positive. So as you can see there, if the torque is in this direction, that is the anti-clockwise direction, the torque is taken as positive, but if it is moving in the clockwise direction, then torque is taken as negative. Okay, the SI unit in which we will measure the torque, or we will solve the problems related to the torque, then we have to check the unit that should be in Newton meter. That was the small topic about the torque. Hope you understood it. If you have any question regarding this torque, so you can put your question into the comment box, or you can contact me via WhatsApp or through my groups. I will try to answer you people. So till the next lecture, see you and Allah Hafiz.